so you have to sort of learn the whole thing. So it says there's an underground conical tank, so important word here is cone, so you know that it's going to look like the shape that I just showed you. And it's standing on its vertex. So you can have a situation where it's upside down, where it's standing on its base. And here, it's not standing on its base, it's standing on its vertex. So it's like the cone that we just saw in the picture a minute ago. And it says being filled with water at a rate of 18 pi cubic feet per minute. What did they just provide us with? Alright, so in this problem you want to begin with making a cone, alright? Remind you of the good old geometry days. It's a joy teaching you in geometry. So you want to write down that your dv dt is going to be 18 pi. Now if anybody here is like, how did you figure that? It's because of the fact that that says cubic feet. The only thing that's cubic is volume. And if it's per minute, that means it's a rate of the volume. So it's over dt. If the tank has a height of 30 feet and a radius of 15 feet, so basically, just like the picture I showed you a minute ago, what you want to do here is you want to take a minute and go into this cone, and you want to make the height like this. And how much did they say the height was?
30.
So you want to call that 30 feet. And then you want to go to the top there, and that is the radius, and that is 15 feet. Okay, so you want to mark those two things as well. Okay, now we're going to read the rest of it, and you guys are going to help me figure out what did they give us and define the question for me, okay? How fast is the water level rising when the water is 12 feet deep? What do they mean by 12 feet deep? What have they provided us there?
The height of the proportional triangle.
The height of the water. It's not the height of the cone. The height of the cone is already there. So, just to be clear on this, there's a height to the cone that they will provide to you, and that's not going to change through the problem. You can write that down if it helps. And there's a radius to the cone, and that is 15 feet. It's not going to change. What will change is the stuff you're putting inside of it or you're taking out of it, okay? So that has a different subscript. You would write that as the height of the water, and they said that that's going to be 12 feet. So notice that they're not giving you a time, they're giving you a instant where the height is 12 feet, and you have to figure out other things about it. And speaking of other things, can you define the question for me? What is it that they want? Alright, so write down the question that they want dH over dt. Once again, I remind you kindly, this question is not about the cone, it's about the water inside the cone. So when we say dH dt, we're interested to know how fast is the water level actually rising. So there you go, it's important to define the question, especially in this problem over here. Now, let's take a look on the inside, just like we had a minute ago in that diagram. What's going to be happening is you're going to have a triangle. This is the height of the cone, so that is 30 feet. And it is a right triangle because this is a right cone. And this is 15 feet. Now, when they said that they're interested in a point where the height of the water is 12 feet, we're measuring things from the ground up. So you're going to go in and you're going to say, okay, so you're saying that the water is over here somewhere, and its height is going to be 12 feet at that instant. So I'll write it in blue for you, but once again, that only represents just the height of the water there. So in geometry, this would have been very easy for you to just really quickly do. And they also test on it in the ACT. But how can I figure this over here out? Okay, so set up a proportion.
15 over 30 and then
Alright. So that way we'll also know what the radius is going to be at that point. So go ahead and solve that for me while we're looking at things. Yeah. Right, so if you don't know how to do that, that's going to be 30 over 15 is equal to 12 over the radius of the water. And so when you guys do the math here, what is it that you end up with? 6. Thank you very much, right? So you end up with the radius of the water is going to be 6 feet. Now we may or may not need that, but it's always safest to actually just be ready for it if you need that. Now, one thing that you need to do separately is to tell me what is the equation that we're going to be needing.
When it says 12 feet deep, doesn't it mean from like the top of the cylinder down?
Because it's an underground conical tank, and when they're filling it, they're saying like from the bottom of it to this, that is the depth of it. Okay, like when you go to a swimming pool and there's a number written on the swimming pool, 5.5 is the depth. That means you started from the bottom of that swimming pool and went up to the water surface, going 5.5 feet. Okay, I've also wondered the same thing actually, so I'm glad you asked that question. So what's the equation that ties in all these three things?
The volume.
Volume, right? What is it?
1/2. Wait, is this the one I said yesterday?
Yes, this is the one you incorrect. Yeah.
1/3
1/3.
pi r squared.
Good
H.
job. All right. So volume equals 1/3 pi r squared h.
They don't provide these, right? You have to like know these.
That's a great question. Actually, they have started to provide them in more recent days. The only ones they don't give now is the area of a circle
That's fine.
and the Pythagorean theorem. So they've actually started to give spheres, cones. They said like we're not testing them on geometry, we're testing them on calculus, right? Okay, so we gotta start wrapping this problem up. What do we do next?
The derivative? Take the derivative.
Okay, go ahead. Take the derivative. Who's absent today?
Nadia.
Oh, Nadia's out. Okay. Alright, so take a look at my derivative and take a look at your derivative. You guys will notice this is the same thing as the cylinder problem because the cylinder had also pi r squared h, right? So first we gotta make sure you know how to take the derivative. Are you guys good with the derivative or do you have an issue with it?
Yeah.
You guys are good? Okay, now let's go through, here's where the problems start. Take a look at what they've provided us in the question. Alright, let's just go through it. I will ask you a few things, inshallah. Do I know the dv over dt according to what I have given?
Yeah.
Okay, so this is good to go. No problem. Do I have the height of the water in the instant I'm interested in?
Yeah.
Do I have the radius of the water?
Yeah.
I actually have both of those. Right? Remember, we're not talking about the cone, we're talking about the water. The thing that's changing is the water, not the cone, right? Do I have the rate of change of the radius? Okay. And notice that they didn't ask me for the rate of change of the radius, they asked me for the rate of change of the height. So obviously then I also don't know height. But I do know the radius squared. Okay, so there you go, there's the problem. You have one equation and you have two unknowns. That means you need to bring some other equation from somewhere, otherwise this thing is never gonna get solved, okay? So I wanted you to realize why I'm about to do what I'm about to do, and basically what you need to do now is you have to go back to this diagram here, and you have to make an equation that is going to be comparing the height and the radius of the cone itself, because that shape will always stay the same no matter what the water level was. It's always going to be in the same ratio, that water level. So notice how Yusuf said this is 6. So 12 and 6. That's understandable because it's similar to a triangle that is 30 and 15. So it's got to be proportional. So for instance, If this thing went down to like 6, what automatically would have the radius to be?
3.
It'd have to be 3. So they're always gonna be in a 2-to-1 ratio. So what you need to do before you start with the cone problem is you actually have to write down a ratio of the height of the cone to the radius of the cone. Again, if you're gonna ask me, but why do we do that? It's because you saw what happens if you try to do it otherwise. You're stuck. You can't solve the problem anymore, right? So the ratio of the height to the radius. Please don't be confused between the water, even though we could use 12 and 6, but 30 and 15, when you go ahead and you do that, you end up with 2. So you end up with the scenario where the height is equal to twice the radius, or give me another way to say the same thing.
Half of radius
Radius
equal to
equals
half of
half.
Okay, so you need to put both of those pieces of information down. And now let me help you tell how do you figure out which one do we need and which one do we ditch, right? So you have to go all the way to the question. And you have to ask yourself, so some years they ask dRdt, some years they ask dHdt. You have to ask yourself, what do they want? What they want is dHdt. So if what they want is dHdt, what you do is you manipulate this equation. Just watch how I do it and then you guys will learn it. So you take the volume equation that reads 1/3 pi r squared h. Because I need this side to be all in terms of h, and if you're wondering why, it's because I eventually need a dHdt to come out of it. What I'm going to do is I am going to use this combination. I'm going to use this combination and I'm going to replace the r with an equivalent of h over 2. So this is going to read h over 2 squared times h. Once again, that's like a really quick step, but you need to know why we did that step, okay? You do that step when you look at the question they're asking. Based upon the question they're asking, you pick one of these. So if I can summarize for you, what we wanted was dHdt. That's why I chose this combination. When would I have chosen that combination? Okay, so you may want to make a little note about that, is if we wanted dRdt, you would have used that other combination, all right? So, now you guys see why I made the pick. After this, the problem is very straightforward. So, what we're gonna do now is we're gonna write down that actually the volume of this cone, not every cone, but this one in particular, is going to become h squared times h, which is h cubed. And then what's 2 squared multiplied by 3 going to give to you? 12. So write down that this is the new equation of the cone. You're not going to use this equation at all. You're going to throw that out. I only showed it to you because I want you to realize there was an issue. Okay, so let's start all over again. Take derivatives. The derivative of volume is dV over dt. The derivative of height is going to give you 3 over 12, so you can make that into 1/4 later. 8 squared. What do I need to make sure that I multiply by? dHdt, right? So because you need, otherwise you'll lose the whole thing. Okay, now let's just go ahead and plug in to make sure, because there's a lot of heights on the board, so you need to know which one am I supposed to plug in. So the dV over dt you know is 18 pi, so you're going to make that into 18 pi. You can go ahead and make the 3 over 12 into 1 over 4. The pi sticks. H. This is a really silly point to then mess up and get the whole problem wrong. It is not, once again, the height of the cone, it is the height of the water in the cone, right? So the height of the water in the cone is 12. You're going to go ahead and put 12 squared over here. And then you're going to do a little bit of math to figure out what dHdt is going to be, okay? So altogether, that's 12 squared is 144, divided by 4 is 36. So this will become 18 pi over 36 pi. And that is the rate of change of the height with respect to time. So in other words, you end up with 1 over 2 feet, and it was per minute, so 1/2 feet per minute. So that right there is the cone problem. Now, before we wrap up here, what if they gave you the same setup, yeah? But they changed this question, or they supplemented this question with a second question, and the second question says, find dr dt.
I can use the original form.
What do we do then?
Like we take that and then put it.
Okay, so you're saying we then go over here, and we take what we know now, and plug it in, that's fine, okay, that will work.
Is the other h is equals to.
What I meant to say is, what if we never ever actually found
Oh, then
dh?
you
And you
use
just
h equals to.
Okay, so, just to make sure, cause I don't get time to do this problem again, so, if you end up in a situation where they ask you the other one, here's how things will change. You would use this combination over here, and what would happen to the volume formula is it will look like V is equal to 1/3 pi, and you're not gonna replace in for R, because if you replace in for R, you will lose your R, and therefore you'll lose your dr. You don't wanna lose your dr. So you would keep your R, like that, but what would you replace the H with though? 2R, so this would become like this, and then you'll have, well, we haven't taken the
Yeah,
derivative
yeah.
yet, but this will become 1/3 pi R cubed, and then you could go ahead and slide the 2 all the way to the top over here, and then you would go ahead and take a derivative of this one over here. I wish there was a quicker way about it, but that's just kind of how this problem is. And I still remember my physics teacher told me, don't worry, it probably won't be on the AP exam. And I swear to God, that was the exact question that was on the AP. It wasn't even multiple choice, it was the free response question that year, and I'll show it to you guys. So, anyway, it's a pretty intense problem. It gets easier after this, so don't worry. I think that's like